A theory of deep integration-based education and conflict resolution. Foundation, approach, and evaluation methodology. Elliot Pines, PhD, CT. First International Scientific Pedagogical E-Conference, October 2021. I welcome you with a warning, but a promise too. The warning is that we will first travel deeply into a converging common picture in a variety of sciences, into which we shall take a speculative jump just a little further. Though just a foundation of a hopeful higher goal, this will take about 75% of this presentation. Because were I even to suggest what is herein but a half a century ago, I would have rightly been considered insane. I therefore need to show you that what I follow here is the path of potentially breakthrough scientific development and not of pseudoscience, and following according to three timeless adages of the philosophy of science and clearly explaining the breakdown of a fourth. As well, I follow in my overall approach laws set down by one of the 20th century's greatest futurists. The promise is at the end, the approach will be practical and should only benefit the students, certainly in no way harm them, even in terms of wasting their time. Only positive results are possible. The only question is whether positive in a merely evolutionary manner or a fully revolutionary manner. The evaluation methodology, just a kernel for now, to be much added to, is meant exactly to measure the results objectively rather than subjectively tainted by examiners' wishful thinking. Please know that in the time available, I can only offer the briefest outline of all this, striving for clarity rather than depth and detail. I am writing a full paper, hopefully to be published by Erie in the near future, where that depth and detail will be offered as well. We begin some 90 years ago in two interdisciplinary themes of the natural and social sciences, but not connected with any school curriculum. Rather, these were two partnerships between a physicist and a psychologist. The nature of the first relationship between Albert Einstein and Sigmund Freud was on the question of why war. However, after their brief correspondence in 1931 and 1932, for Freud could only offer the depressing analysis that war was an inevitable consequence flaring up from the violently aggressive nature of human egoism, the independent concerns of Freud and even Einstein grew darker over time. Freud understood the growing nature of human ego, especially in watching the rise of fascism and the particular viciousness of the Nazis. After World War II, Einstein saw the power of nuclear fission and fusion in the hands of that ego to his utter terror. Both men went to their graves with a sense of virtual hopelessness for the future of humanity. The nature of the second, between Wolfgang Pauli and Carl Jung, was more upbeat at first and lasted from 1932 to 1958. It was held by the fascination of both men of a potentially deep underlying relationship between physics and psychology, if you will, the hazy dreamlike nature of quantum mechanics and the hazy quantum mechanics-like nature of dreams. The relationship broke down eventually as Pauli pulled away from Jung, as the latter further developed his theory of synchronicity as a proposed relationship for a causal simultaneous occurrence of similar events. Initially, starting prior to even meeting Pauli, Jung took this as a psychological phenomenon, how humans tended to perceive the world. However, over time, he developed the notion that the mind was also causing such effect in external reality. However, there was a fundamental difficulty concerning testability, as one could not provide a priori probabilities on events unknown until they happened. Further, a parallel idea in quantum theory, as we'll discuss later, was both introduced and challenged as being physically, even mathematically impossible by Einstein with the help of colleagues Boris Podolsky and Nathan Rosen. It is interesting that Einstein had reservations about Freud from the start, as he found psychotherapy highly questionable as a science. We see that Pauli might have abandoned Jung's coming to a similar questioning about how psychologists approach science. It is not surprising that decades later, Richard Feynman, as published in the Feynman Lectures on Physics, refers to psychotherapy as possibly being a form of witch doctoring. Views will change drastically due to developments after the deaths of Einstein, Freud, Pauli, and Jung. Ironically, these events were initiated by Einstein in his lifetime, who expected opposite results. A new age of mystery would open up in physics, followed by another far more shocking wake-up call than Einstein's attempt had been. This will invite psychology back in a most powerful manner, leading to the proposal of this presentation. Let's start with the festering concerns of Freud-Einstein. I'm going a bit beyond what is intended for the eventual paper, but I wish to give a broader, updated taste of these. So I'll go somewhat fast for the next few slides, but you can review them at your own pace when this presentation is later posted. However, I do this only because the importance of a problem can make an uncertain solution more worthwhile pursuing, and there is none more important, as it is basically all of our problems combined. While we've made it this far, the dangers that so concerned Einstein and Freud have only broadened and deepened with globalization, whose discontents well exceed those that Freud saw in civilization decades back. Socioeconomic and technological factors pull us together into a global village. At the same time, our rugged independence and superiority egoism, expressed in isolationism or attempted domination from the level of multinational shared ideology bloc down to the level of particularist nationalism, subgroup breakaway, and individual immediate self-interest, make for an explosive counterforce. The result is a fire of violent aggression and an economy freezing ice of mistrust. And indeed, who by fire and who by ice? Since the 1950s, a change in sales pitch mixed with a degradation of the American character and magnified to the world along with American culture due to film and new video media dominance have led to a huge consumerism problem. The consequence, beyond impoverishing large segments of the public, is massive production of needless things, artificial obsolescence, and seemingly insurmountable resource and waste management issues. Einstein showed the way when he said, we cannot solve our problems with the same thinking we used when we created them. So AI should be just the ticket. I mean, Alan Turing helped win World War II with a computer, so let's build better ones, thinking ever faster and smarter than we do. Indeed, careful entry into artificial intelligence with limits and a revamp of our society around it would be a great boon to humanity. However, it's not the solution, and until we have one, it is potentially the worst of our problems. Our greed to speed into it, not share the wealth of it, and act in personal and national interests and other non-unified manners is racing us along a path that we are not prepared to take. Concerning the four issues of AI mentioned in the slide, I emphasize that if we overcome the ego problem, we can slow things down or perhaps speed ourselves up to properly direct AI development without matters getting out of control. If so, AI can still prove a channel of partial utopia. But if not, we'll have 1. The economic disruption, possibly without relief, to possibly the majority of individuals and families in industrialized countries over the next decade that I think is all too well understood. Einstein saw such coming even with the simple automation in his days. 2. The bugs in the system get ever deeper and ever more serious. Examples. A program training to pilot tour ships and the like was given a game to play where it was to optimize time in traveling about a virtual bay. The program identified weak links in the game program and was able to override rules such that it could take shortcuts that involved destroying other ships, killing people on the docks, etc. Deep learning to identify wolves from dogs for automated killing in Alaska identified huskies as wolves because of the wintry outdoor environment that they were both generally pictured in. Parole determination programs inadvertently racially profile rather than judging solely on case-by-case basis and are embedded into the criminal justice system. A woman killed by an AI car, unrecognized for not being in the crosswalk. At a demonstration of a new U.S. military robot with kill decision capability, it identified hundreds of spectators as the enemy and was barely tackled in time by an alert and courageous Marine. Such problems are locked into a pattern of statistically expected catastrophes proportional to the extent of independent AI task responsibilities starting in the immediate range of AI actions just beyond human ken. This can be understood regarding Kurt Gödel's incompleteness theorem applied to guideline preparation and the deeply related undecidability problem uncovered in Alan Turing's analysis of the halting problem. 3. The first strike military concerns are straightforward, I think. 4. As to the ultimate threat of the AI singularity, there are more ominous implications per Gregory Chaitin's algorithmic information theory, relating to his theorem proving that mathematics can have no theory of everything. This tells us that not only is there incompleteness in any set of guidelines, as Gödel showed in an earlier generation, but what is not missing is very finite. If the late Stephen Hawking's prediction of an AI singularity around 2045 comes to pass, almost immediately AI will be dealing with undecidable propositions no matter how well we set up criteria, and will be solving these by its own pattern recognition methods and randomization. Any way you slice it, it will be a statistical drunkard's walk relative to what we should want. This means that decisions and actions that we don't want, to put it mildly, will begin to occur with breakneck speed, becoming increasingly bad according to the square root of the number of decisions involved, exponentially more mysterious, ever more difficult to trace, were we to have a clue where to even look, and ergo, increasingly more difficult to detect in time to stop. Now, some have suggested a cyborg approach. We'll partner our individual brains with AI and we can control it. Here's a physical analogy. Tie a mouse's legs to that of an elephant that keeps growing, and let it stampede. Even if the mouse wasn't torn apart, it wouldn't have the foggiest notion where the elephant was going or why, as the countryside went by in a blur. To explain, if a computer deals with matters too complex for our individual minds to handle, except in the vanishingly few cases that the computer can discover symmetry to simplify things, like the sense made out of an orchard layout once you look in the direction of the columns or rows of trees, we are totally clueless. Let's go explain calculus to, or stuff an encyclopedia into the head of, a child too young to even count to 10 or repeat the alphabet song. In any case, eventually it would likely be impossible to stop the AI, as it will almost certainly put in error correction mechanisms regarding simple entropy on up to its nonlinear system level version, Murphy's Law. That is, in simple terms, it will defend its mission. Sounds ominous? It's more than just ominous. Considering all the systemic problems, yes, potentially including new, perhaps worse pandemics, and threats out of the complex overlapping woodwork that we can't yet identify to predict, things are challenging. One up and coming is the power of technology and media, particularly social media, for covert manipulation and control, and its exploitation in the hands of a few. However, we can hopefully overcome it all and enter a much brighter tomorrow. We may be capable of changing the game scenario from a very high level of control through methods of connection and unity. Much is attempted today along these lines on a lower level, and Freud might rightly shake his head sadly that we were trying to build something new that human ego just wouldn't allow, even in its ultimate best interest. However, what if this is really not a matter of building something new, but just realizing a holistic system that was already there? Can such a notion be real? Let's now turn to the direction of Pauline Jung, but with some preparation. To quote Morpheus of the movie Matrix, what is real? The classic opinion is the natural common sense one that there is an objective external reality, reasonably reproduced by observation with our senses, and then send partially processed information up our nervous systems to our brains, where we would form our mental map of reality by aligning, coordinating, and translating that information into knowledge and fitting it into a developing framework, a working model of the world with which we generally successfully interact using it. We might call this the idea of a separate knower, knowledge, observer, knowledge, perception, and the thing known, reality. That reality was material with sensory properties. The knower, using focus and pattern recognition, took sensory input in small spatial and temporal pieces and stored them in a manner that could be reconstructed through associative memory and the logic of cause and consequence. The extreme of working more with the original sensory input holistically became the forte of right brain people, those particularly attuned to humanities and or art. The extreme of total representation in abstract reductionist manner became that of the left-brainers, scientists and mathematicians. However, there is a classic variation on this materialist theme, that the mathematical deconstruction was actually uncovering a higher ideal mathematical reality hidden in material forms. In particular, this Platonist view is held openly by some mathematicians and likely to some extent by all. Now let's see what is becoming clearer in recent years. But first, let's see how to see. Arthur C. Clarke, one of the outstanding futurists of the 20th century, gave us starting laws of getting to a revolutionary or breakthrough science. 1. A distinguished but elderly scientist states that something is possible. He is almost certainly right. When he states that something is impossible, he is very probably wrong. 2. The only way of discovering the limits of the possible is to venture a little way past them into the impossible. 3. Any sufficiently advanced technology is indistinguishable from magic. We'll get to the example par excellence of laws 1 and 2. Our holy grail is 2 and 3 together. However, first it is necessary to clarify magic and the impossible. Pseudoscience and revolutionary breakthrough science both seem like magic, the impossible. Real magic would be the manipulation, certainly sensation, of form abstracted from all substance, ergo non-interactive. By definition, this is truly impossible. Pseudoscience isn't magic, it's a magic trick, a fool's faith below present scientific reasoning, as it just hides part of the radar screen that we already have. A little investigation and the trick is unmasked. Examples: perpetual motion machines are seen and interact, so must slow if not re-energized. The only flat earth arguments in the form of reasoning prove a circular logic, with a hidden a priori assumption of a flat earth. Why doesn't an airplane's angle of inclination change if following a curved sphere? It's because the angle of the ground and the line of gravity to the Earth's center themselves change, of course. Revolutionary science doesn't hide anything, but rather deals with a potential area off the radar screen, which is why Clarke refers to it as the impossible. It starts off with our present scientific reasoning and then takes one step of faith above that reasoning. The research may prove wrong, but the methods are not lies. Let's talk about some long-standing reality checks from the philosophy of science, beyond acceptable methods. If there's going to be a measurable reality, it will need to be represented as a positive real number. Truly negative numbers, certainly complex numbers involving the square roots of negative numbers, are not actual measurables in our reality. In the end, there is also no absolute vacuum. And as well, on a similar principle, there is always something beyond a boundary. Further, there are no absolute discontinuities. We cannot go beyond 2 points on a line without crossing all points in the middle, or more generally, 2 points in an n-dimensional space without passing through all n-1 dimensional planes between them. However, then there is a quasi-check, Occam's razor. The simplest explanation is exponentially, most likely, but only if the series convergence of the probabilities of more complex answers is very rapid. As we will see, this point may cause a major shift in the understanding of evolution. Einstein just wanted to have a real, as well as a peaceful world, but Clarke's first law dogs him at every step. Plus, Einstein had a misconception of his own making. A parenthetical comment that no one takes much note of in Einstein's discussion on Euclidean and non-Euclidean continuum in relativity in section 24 in his 1920 The Special and General Theory. The surface of a marble table is spread out in front of me. I can get from one point to a neighboring one, and repeating the process a large number of times, or in other words, by going from point to point without executing jumps, I am sure the reader will appreciate with sufficient clearness what I mean here by neighboring and by jumps, if he is not too pedantic. We express this property of the surface by describing the latter as a continuum. Just what did Einstein mean by "if he is not too pedantic"? It appears that he is trying to ignore the problem of infinity brought up in ancient times by Zeno of Elea, and thus, ironically, his words don't support, but rather actually ignore the principle that nature does not make a jump, as between two neighboring points, there is always another neighbor. Per my paper and presentation for the Erie Second Scientific E-Conference, The continuum is a slippery slope out of any level of perception and mind map. Einstein was doomed to be trapped for the rest of his life in an imaginary universe with infinity and infinitesimal paradoxes galore, as well as quantum jumps between neighboring points, things just getting worse after his death until breakthroughs of this past decade. To trace the highlights of this fascinating history, general relativity, barely a year after its publication, led to the singularity of the black hole physics realized by Carl Schwarzschild in 1916, and that of the Big Bang by Alexander Friedmann in 1922, approaching infinite information per Nobel laureate Roger Penrose in 1984 and 2004. There are no finite positive real numbers here, but it can't be measured anyway. However, in 1949, Einstein's colleague Kurt Gödel derived from general relativity an alternate universe where, so to speak, everything spins, where one could enter a closed loop in time. He argued that if future and past could be the same in any valid universe, that time didn't actually exist anywhere. Yet time locally has a finite positive real measure. It's like looping Escher-Penrose steps. Per the movie Inception, it's a great way to hide the fact that you are in a dream. This, of course, doesn't bode well for the space part of space-time either. In 1935, Einstein discovered a new property implicit in quantum mechanics, entanglement, that directly violated any notion of space and time, that he felt proved that quantum mechanics was just an approximation to a deeper theory. However, in the early 1980s, in a series of experiments, Elena Aspect et al. Demonstrated the after effects of entanglement were measurable, positive real numbers. Finally, the only way that Einstein's theory successfully explains relative acceleration, established in the 1980s, requires essentially the same violations of time and space as entanglement does. It is noteworthy that in 1954, from his own difficulties in his search for a unified field theory, even Einstein himself began to suspect that the notion of space-time might have to be dropped altogether. One wonders if he did begin to realize that his physical instincts that visualized relativity for him and bristled at the thought of quantum mechanics might only be about a simulation, or I guess in 1954 the analogy would have been a cartoon. Google the cartoon laws of physics sometime to have some intellectual fun. Per the above and what follows, it is now known to be far broader than just quantum mechanics, but there is something indeed very wrong with our perception of reality. Before leaving quantum mechanics and relativity for deeper waters, if you ever want to give a quantum mechanics wow taste to even young students, I got 10-year-old students at least to quickly realize that this should be impossible. All that you need is 3 polarized lenses, 3 polarized sunglasses, or 2, if you're willing to pop out a lens from one, will do fine, though harder to manipulate. Show the ceiling light through one lens. Okay, darker as expected. Take a second one in parallel and turn it 90 degrees, which will be the darkest point. Okay, the first blocks one kind of light and the other blocks the rest. Maybe not perfectly. Real experiments are not perfect. Then place the third lens at 45 degrees between the first two, and instead of making things darker, a magic window opens to let more light through all 3 than the first 2 alone. This introductory demonstration was first suggested in 1930 by Paul Dirac, who won the Nobel Prize for his prediction of the existence of antimatter by applying special relativity to quantum mechanics. There are yet more serious revelations due to the ever more apparent integrality of nature. Hot on the trail of quantum gravity, theoretical work on black holes from the 1990s till today have led to even more startling realizations of the meaning of the holographic principle than what the slide says, and the true meaning of this alone will fully start to hit home with the next slide. However, out of this comes Verlin gravity, equating gravity with entropy. That must be considered along with the ER equal EPR theory, equating gravitational wormholes in black holes with quantum entanglement, and orchestrated objective reduction, postulating the collapse of the perfectly linear quantum mechanical wave function to a measurable actual by its interaction with a quantum of curved spacetime, the theoretical gravity particle or graviton. Putting these three together comes an unavoidable principle that one of the founding fathers of the holographic principle and ER equal EPR, Leonard Susskind, often speaks on. All the reality that we perceive actually lives on an effectively two-dimensional viewing screen that surrounds us like an IMAX theater, including below in this case. Yes, ironically but true, to say that we've a flat Earth is a pseudoscience, but to say that the entire universe is flat is not only science, but so much so that it was deemed a principle. We've lost over years of hard research work here that shows clearly that the latter claim is a sophisticated level of scientific model. However, the former remains merely a paranoid fantasy already disproven over 2,000 years ago. Further, though, it's not just a screen, but rather every person has their own personal edge of the noble universe, traveling along with them like a shadow to maintain the illusion. Now, this is what we could call a real theory of relativity, only we haven't gotten anywhere near the real question yet, the one which will lead us back from science into education. To break free of this orbit, and such always means overcoming gravity, we note something about the very gravity, the curvature, invoking the screen in the first place, as well as mass, including ours, and all forces and interaction within and between in this world before us. They are a result of a breakdown of quantum entanglement, a world of pure linear, that is, superimposing but non-interacting abstract form. If you have really been listening to this presentation so far, you should be asking one question and screaming out another. The calm one: if gravity, even making the world impossible, only comes from the breakdown of entanglement by already existing gravity, how can gravity or the world exist in the first place? It's a dog chasing its own tail. The one you should scream, as you would at any liar that you caught in the act, is, you said it earlier that real magic is a lie because one can't interact with abstract form. It can't inform if it's not in a substance to give it form. Let me ignore the first question and try another swindle on the second. Well, it does have substance. A vessel to capture it. Why, this universe, of course. We can measure quantum after effects here. Then you can say, oh really? Considering both questions, how does non-interacting abstract form interact to create its own interacting substance and subsystems and systems? Out of what and by what process, pray tell? Please hold that thought. As well, don't lose notice our little relativity extension observation just before, because we ain't seen nothing yet. Hang on to our hats, your hats, although even general relativity still doesn't really tell us the reason why it's necessary if there's no wind blowing. And let us go on to deeper dips in the roller coaster. As the upcoming fourth Matrix movie reinvokes the question, how deep does the rabbit hole go? There is some depressing but expected news. I'm afraid space-time is doomed. Nima Arkani Hamid spells it out for us. We might call this slide Reality Strikes Back. No space or time, no relativity or quantum mechanics. This is the easy part. The hard part is what might take its place, that is, realer. The baby that should not be thrown out with the bathwater. There's hard stuff next, but it's only for one slide. Shortly thereafter, we will rejoin psychology, or rather branch into the wider field of cognitive sciences, on the flip side of this coin. We'll find out what this coin is as well. To give a flavor of what he wants to substitute, bear with me here. It's not simple. Relativity and quantum mechanics are considered in this to have been imaginary fixes, like the Ptolemaic epicycles of the ancient geocentric universe model, or the ether theory prior to the Michelson-Morley experiment and relativity. These have led into a complex tangle to try to overcome internal contradictions to the extent of bordering on pseudoscience. It is at such a point that certain on-target avant-garde paradigm shifts, often themselves having been falsely accused of being a pseudoscience for reasons more status quo, psychology, and politics than scientific, come to the forefront of legitimate investigation. What the amplitude concept of Nima Arkani Hamed, Yaroslav Trinka, and others does in particular is return to the quantum mechanical singularities of point particles that superstring theory hoped to be rid of, as well as the relativistic singularities of black holes and the Big Bang, and that holographic theory has only brought paradoxical results to, hope to solve. Instead, the amplitude deals directly with the quantum field theory and early universe inflaton field theory as one, and analogously handles these singularities as mathematical ones are handled in the complex plane that determine identical values for all paths enclosing them, per the Cauchy residue theorem. It is of no matter the difference in how long the path or how much time it would take to accomplish it. The end is the same. In a nutshell, in this case, a virtual n-dimensional one, but actually keeping the idiom of simplification as well. This appears to lead to a form 7 polytope in a 4-dimensional mathematical virtual space using methods of projective geometry and linear algebra. 4-dimensional 5 and 8 polytope structures are shown in the video to give some flavor of this.
The 5-cell.
Well, classical music is very nice, but we need to hear what's going on here. It forms an integral system effect, an interaction according to its virtual volume, not its independent virtual dimensions. It is a reworking towards a timeless, spaceless, relativity-less, quantum mechanics-less, abstract scale-free network physics. This simplifies calculations exponentially, like taking a car and throwing out everything under the hood and saying that it works better that way. This all seems to float in the unreal, except for two things. One is that the prototype theory was applied to a problem in quantum electrodynamics, I understand, a several-step interaction in nuclear physics whose description required some 500 pages of Feynman diagrams, each of which, by the way, is a matrix tensor analysis. Hope, in simplified form though, hopelessly unsolvable by even the most powerful computers on the planet. However, the answer is known by actual measurement. Apparently, early amplitude theory solved it correctly with just a few lines of equations. The second is that, per the holographic principle, the description of reality also appears to lose its volume and retreat to a lower dimensional boundary screen, though it is more extreme, as there is nothing but an abstract network of nodes, mathematically multidimensional, but without physical space, time, or mass. In short, scale-free networks aren't in space-time. They compose the illusion of space-time. What it boils down to is that if we see a world of space and time, and all our sensory observations appear to be in space and time don't actually exist, physics itself demands that we are living in an illusion. A little of the sound here, the music, as it were, that you should get the flavor because that's important in this case. Here we have an animator and musical artist's conception of the amplitude in action. The problem is that animation and music are themselves trapped in the illusion of action in space over time, of their creators' perceptions and mind maps. The real amplitude here would be better represented in the conceptual path up from electrical state to ones and zeros to final code of a video game on a zero-dimensional thumb drive. The question remains, where is that illusion coming from? Our physical brains and senses apparently only exist in a non-existent space-time. We'll have to look somewhere else. However, in a broader, higher sense, like in a computer simulation of pure mathematics, space is associative memory or relationship, and time is clock progression or that of logical induction. Objects that are identified by momentary isolating focus above their internal composition systems and within their defining external participatory systems are informational entities separated, say, per the Hamming distance, the sum of binary distances. However, simulation comes down to finite mathematics, and all the finite requires an envelope, a boundary condition by definition. And what transforms between pure mathematics and the world that we perceive? Perhaps it's not so much what as who, or rather, does what and who become one question? Perhaps it's time to leave the left brain line of physics and put one foot on the more right brain leaning line of psychology, or more generally, cognitive sciences. Maybe we'll find a unifying middle line. Some teachers might recognize this five-stage storytelling graphic organizer. However, this is not the kind of story that your students usually come up with. It is a true story of scientific, intellectual, and experimental struggle to get at something true of great practical importance. They are time sequenced from the beginning of each stage, though there is overlap in time. In fact, the last four are all active parallels into the present, and in a sense, even with the first, all contribute to a deepening picture. It is a story whose finish here is not really the end, but just the present. I hope that we might be still part of a sixth stage to the story entering into the future. Returning to the Pauli-Jung collaboration of 1932 through 1958, we recall that it's separated as Jung's initial idea went from the psychological effects on pattern recognition to the invoking of patterns in reality by the mind. Again, beyond the difficulties of using a posteriori probabilities regarding hypothesis testing, the causal challenge to microscopic quantum mechanics by Einstein et al. Were already enough of a headache for Pauli and his colleagues to deal with. Pauli likely wanted to stay clear of any idea of macroscopic mentally induced acausal match sets. However, experiments from the 1980s to the present not only prove the reality of quantum entanglement, but that it was in both space and time proven with objects approaching the macroscopic limited in size only by technical, not essential issues. Further, it was proven that quantum histories could be manipulated by observation. This makes one wonder about revisiting synchronicity, although the testability of it remains a question. Also, what is acausals in space and time? Could, in a simulation framework, correspond to inheritance from a generality to specific instantiations. However, again, what or who would be doing the simulating? Holonomy, to describe a bounded wave component series description, is borrowed from a similar use by Heinrich Hertz, who won the Nobel Prize for his detection of James Clerk Maxwell's theoretical radio waves. Already in 1946, Dennis Gabor developed windowed Fourier processes in communication theory application, noting its similarity to the bounded wave description of the quantum description of the atom. By the early 1960s, the Gabor functions, in today's mathematical terminology, wavelets, were developed into optical imaging technology by Emmett Lathe. Further, into the 1960s and the 1970s, experimental evidence began to build that certain processes of the brain map to both local electric field potentials as well as bursts of electrical discharges. Evidence that the dendritic receptive fields in sensory cortices are described mathematically by wavelets led Carl Primbrand to holonomic brain theory. In short, the senses and brain prepare a holistic perception of the surrounding world, a hologram of space and time. In the light of the holographic principle regarding holographic information, nature, the holographic information nature of supposed external reality, produced entirely by linear information transforming to nonlinear entropy per the orchestrated objective reduction, Verlin gravity, and ER equal EPR theories, especially given recent work in the quantum of consciousness regarding the mechanism of sense and thought, an even stranger reality opens up. This process of entropy, grounded in nonlinearity, makes our universe appear as a fractal. This tends to an integral cosmic evolution of integral interaction from a starting point in the direction of infinite Shannon information and a communal biological evolution mechanism on Earth, a tendency towards integral communication and increasing algorithmic information. There appears skeletal structure of scale-free networks. The latest level seems to be the amplitude hedron itself. We'll return to this. Nobel laureate Sir Roger Penrose noted the seemingly mathematically impossible ability of human consciousness to override the limitations in logic set by Gödel's theorem, corresponding to a violation of physical causality. Along these lines, he noted early experimental evidence of quantum consciousness, the discovery that the beginning of mental reaction to a stimuli occurs prior to the stimuli reaching threshold. In short, the mind appears to predict the immediate future, entanglement-like, appearing like a reverse time mechanism. Penrose predicted some unknown, ubiquitous microscopic structure in the brain for this phenomenon. His concept and supposed structure for it were attacked for years as impossible on a number of grounds in philosophy, biology, and physics. Then, Stuart Hameroff, professor of psychology and anesthesiology at the University of Arizona, proposed that structure, the microtubule, important to sensation and motor response down to the subcellular level. Per Hameroff, he had a structure looking for an explanation, while Penrose had an explanation looking for a structure. Of 16 hypotheses of their combined theory, at least 6 have been proven true. As well, the theory solves, as proven experimentally, a few profound mysteries about the functioning of anesthesia on the nervous system going back over a century. Also, a recent unconnected study from a medical research team has led to some powerful new support for the basic intentions of ORC-OR and this first 21st century teaming of a physicist and psychologist in the traditions of Einstein, Freud, and Paul Jung. While it did require some peripheral modifications over time, the core of the theory remains strong. This also supports contentions by other researchers, particularly Eshel Ben Jacob of Tel Aviv University, that there is behavior of such complexity in even microorganisms as per necessity to indicate some simple level of consciousness even in them. Per Penrose Hameroff, this proto-desire, proto-consciousness, bit decision process reaches all the way down to the quantum resonance of certain simple organic molecules, forming a basis from quantum entanglement on for an integrally communicating swarm intelligence for evolution, making use of that scale-free network skeleton discussed in the previous slide. There are 3 major wake-up calls for science now discussed, if indirectly. 1. Finite spacetime can't exist due to its essential paradoxes. 2. The evolution must have a truly causal explanation, given that neo-Darwinism's random mutation violates mathematics, specifically algorithmic information, in its theory and empirically through the huge gaps in the fossil record, as well as the nature of communal evolution via integral communication pathways studied over the past few decades. 3. that consciousness is not an accident of the material organization of the brain and senses, but is rather a fundamental reality. Consciousness is first and foremost an observer, not necessarily free choice. Self-awareness certainly requires awareness, period, as in anybody home? And science is about observation. The inner scientist observes science. Science does not observe the inner scientist. Classically, for science to explain consciousness, it has to explain away the observer. It can define consciousness as an emergent principle out of a complex interaction of causal or probabilistic relationships. But there is no observer, no I. There might be a you, that is, an artificial intelligence. External behavior is not internal feelings, sensors and microprocessors aside. Per John Searle's 1980 scenario of the Chinese reading room, I suggest Googling the term if interested, science cannot differentiate between an entity with an actual knowledge of English and Chinese and a mere algorithm. The Turing test has nothing to do with consciousness, save at what point you can fool a truly conscious observer that he or she is dealing with another one when he or she is not. While the amplituhedron deals with the first with no comment on the other two, Orr does consider a conscious causal development of evolution, and while not claiming simple material emergence, rather a middle line emergence between the linear quantum world of the possible and the curved spacetime of the measurable, it does claim that quantum mechanics is a border of spacetime and thus physics. However, even if spacetime actually existed, the Penrose-Hameroff position is at best a semantics argument, as Penrose admitted in an interview, and Hameroff seems to imply indirectly concerning discussions on deeper levels of consciousness. Stem cell research pioneer Robert Lanza has gone further with biocentrism, where conscious observation determines our reality, including its apparent evolution. His early theory realized the challenge of the solipsism paradox here. How can I be part of reality that you created and you be part of one that I created? As the theory evolved, the natural answer did as well. Higher joint consciousness. If a right thumb rubs a right pinky, consciousness is focused there, and the left pinky is part of its domain. Similarly, my right pinky can become part of the left pinky's domain. Both can be rubbed simultaneously, of course, in a superposition of such consciousnesses. It is interesting that Professor of Evolutionary Biology, Richard Dawkins of Cambridge University, one of the foremost neo-Darwinists in the world, challenged this theory as quantum metaphysics. This is ironic, as such metaphysics has been proven in the laboratory in countless experiments for 4 decades, and his only reference was an article in an Indian humanist journal which used the Einstein-Podolsky-Rosen paradox to make its point, exactly what was disproved countless times by those 4 decades of experiments. Be that as it may, we will see a complete turnaround on this by Dawkins momentarily, when the matter is proven not by quantum mechanics, but by evolutionary simulation. Multimodal user interface theory comes to similar conclusions from a very different track. For many years now, research has shown that what we perceive and what our minds puts together of it is an hallucination constructed from disjoint partial inputs. In fact, reality is simply the common aspect of that hallucination that most people agree with. Much of this seems to come from environmental cues that evolved into instinctive sensory mind assumptions to save time and keep focus. Focus on what? On interests of the ego, most fundamentally, survival. This is where the work of Donald Hoffman, a professor of cognitive sciences at the University of California, Irvine, started. He was curious as to just how important such simplification of reality really was from a survival of the fittest standpoint. After all, common sense seems to say that the more accurate your grasp on your surroundings, the better your chance of survival. What his team discovered after massive research through genetic algorithm simulations shocked them so profoundly that the surviving fittest always showed the greatest ability to simplify perceived reality to the bare bones necessity, that it led to a radical new theory of consciousness and evolution. Per this, nothing actually exists but consciousness. Consciousness that can superimpose into ever higher unified group consciousness in some very complex, more abstract higher reality or realities. These are so complex that consciousness evolved to produce our imaginary world in the same way we create the simplest possible representation of computer functions via an icon interface. Placing a folder into a recycle bin on a monitor screen or recovering it makes the decision and action process a great deal quicker and more correctly done than dealing with the actual reality of millions of rapidly shifting transistor voltages hidden from our eyes inside the computer. The data was, in fact, so convincing that here Dawkins was willing to accept the possibility and told Hoffman that he could see how evolutionary principles could be pulled back to a higher plane rather than what we immediately perceive. In fact, Dawkins has in general become open to the broader idea that ours is a simulated reality. This is a 180-degree turnaround from his Occam's razor approach to challenging the religious concept of a deity. That argument was that whatever the mathematical difficulties in neo-Darwinism for the ecosystem and humanity arising out of chaos, it was a far more logical starting point than a vastly greater being that could create it all itself arising out of chaos. Now it turns out that it might be more logical that a greater informational reality, or ever greater ones, arise in far greater solution spaces that then simulate more organized sub-realities that could have naturally evolved in those. This is a legitimate realization on his part. It is a long tail to non-convergence breakdown of Occam's razor, a perfectly reasonable switch of perspective. To follow Professor Hoffman's analysis of the unification of consciousness and speculating perhaps beyond where angels fear to tread, expanding outward and upwards into greater connection and unity with humanity and nature, including our increased perception of it, we theoretically could head towards an ideal of the knower, observer, knowledge, perception, and thing known reality as three views of the same unity approaching infinity, taking into account the idea of a non-convergent long tail breakdown of the principle of Occam's razor. The basis for our perception is egoistic, survival of the lowest level at the lowest level, but likely refined by human level ego in its goal focus, like selfish wealth, power, and knowledge. What could be achieved at the level of more abstract consciousness if we could overcome such blinders below? Could groups unify into a higher perspective, one that could reach unheard of levels of problem solving and creativity, as well as achieving a true sense of mutual responsibility that could steer the world to safety and a brighter future? Let's see if it's not worth a try. How would these mathematical and humanities views combine along with a unified consciousness? Well, in the human lexicon, there are but three expressions for initiation of a state of being. 1. Chance. 2. Causal chain. 3. Prime mover or first cause. That is free will. If we take into account the principle that nature does not make a jump, it becomes clear that chance, not just our lack of knowledge, can't come between steps in causality, nor can it be first cause due to the principle that nature abhors a vacuum. Only infinity itself could be first cause. This is also why, for one thing, quantum mechanics alone would have doomed space-time. As to infinity, again referring to my 2D Erie scientific e-conference paper and presentation, logic completely breaks down at infinity, save its unity, causality, and the probability distribution implicit in chance are non sequiturs there, so that, so to speak, only free will is left. I apologize if some of the above sounds too poetic to the reader, in fact religious, but entering the realm of consciousness itself forces one to anyway deal paradoxically with what is at once object and subject, mathematics and humanities, science, art, and culture. And yes, even its religious expressions, all forms of perception and expression are all part of the complete integration, Further, in noting the foundation above, one cannot but wonder if some such matters were actually intuited by purer, that is, more uncluttered and less egoistic ancient minds, becoming hidden within the language of human religious culture. Einstein expressed such thoughts, and likely in this regard did he proclaim that religion without science was blind and science without religion was lame. He, Gödel, Emil Post, Frank Tipler, Lanza, and Hoffman felt similar issues in the descriptions of what they studied. In particular, Tipler's introduction to his version of the omega point theorem, in this author's view, the rightful predecessor of today's various versions of the simulation hypothesis, goes to great lengths to explain his use of the appellation God for the omega point due to a colleague's complaint that he was spoiling a beautiful, purely scientific theory by doing that. In Post's case, a paper was rejected from publication, apparently as an appendix analyzing self-reference, also found the need to describe an infinite regression as God. Einstein, too, used God as though an unavoidable metaphor, or perhaps an actual reality, regarding the wisdom he saw in the cosmos, as it were, the creator of the unified field theory that he struggled to find, and the boundary condition of its grand differential equation. Einstein did write that he found the concept of a non-physical afterlife, some higher reality of pure consciousness, untenable, nor would he even want such an existence. However, However, his close colleague and friend Gödel wrote another colleague who was dying of his certainty from the pattern of proof developed in his incompleteness theorem, an approach that he also applied to Einstein's field equations to show that time did not actually exist, that the mind continues after death. Tipler's theory continues existence via reincarnation as a personal emulation in a simulation, as do some versions of the simulation hypothesis. Lanza is at least one lecture took the basic solution of the solipsism paradox to its ultimate implication, a root of absolute unity in infinity. All paradoxes end there, which he felt impelled to call God. Hoffman has us as an abstract individual consciousnesses that can unify in ever higher groupings, also until rooting in God. Perhaps, he doesn't say to my knowledge. There is far more to say on this subject, but let it suffice to basically reiterate the beginning of this aside at its closing, with the closing of a 2007 article on holonomic brain theory by Dr. Carl Primbrand of Georgetown University. My hope has been that as scientists begin to understand and accept the validity of holonomic processes as truly scientific, this understanding will help resolve the current estrangement between the sciences and the humanities and between sophisticated pursuits of science and sophisticated pursuits of religion. I'm sorry about that. Let's do that again.
One pill makes you larger, and one pill makes you small, and the ones that mother gives you don't do anything at all. Go ask Alice when she's 10 feet tall. And if you go chasing rabbits, and you know you're going to fall, tell 'em a hookah smoking caterpillar just soar. When the men on the chessboard get up and tell you where to go, and you just had some kind of mushroom, and your mind is moving low. Though Astralis, I think you'll know.
When math, logic, and space proportion have fallen sloppy dead, and the white knight is talking backwards, since for the hour of time it's off with her head. Please forgive my singing, but more importantly, please know that I take the opioid addiction crisis very seriously. However, in a deep sense, our job is to bring students into a better sense of objective reality and to help them make a good future for themselves and the world. It is true that the rock band's name is also the slang for V-shaped tweezers used to hold a marijuana joint, and that White Rabbit is considered a classic of the psychedelic genre. A nice way to say druggy songs, like the Beatles' Lucy in the Sky with Diamonds. However, Grace Slick did claim that the song was a critique on parents not thinking about the negative influence of even children's classics whose fantasies could inadvertently promote the escape from reality of modern drug culture. She further claimed that the ending of "Remember what the Dormouse said, feed your head, was a message that youth should get their high from education, not drugs. So how to safely try to get our students off the space-time ego drug and do it at near zero cost? It is simple. Merely extend the best state-of-the-art practices for socialization, team building, and student-centered group learning. Students will discover themselves in each other at deeper levels until there is a resolving, accepted whole that they realize is above them individually with a judgment that they willingly bow to. It must in the end be willingly, as though a child were visited by his or her adult self from the future, and would certainly realize that it would be best to follow their own wise, experienced adult advice. The Latin root of education actually is a matter of controversy between two possible roots: educare, to train or mold, and educere, to draw out. While classical education seeks to train and mold, and more modern education seeks also to draw out in terms of understanding, thinking, creativity, the truly ideal is to seek to draw the students above themselves and then, with some teacher guidance in the process, let the result itself mold and train the students. Further, there's much talk nowadays about the idea of a growth mindset as a key to student success in the classroom and in life. It is the passion and perseverance of not going for the easy way out or just the grade, but going after the skill of learning. Improvement for improvement's sake, due to love of a discipline or subject matter. This was sought out as similar ideas to cure the growing malaise in education. However, such a discovery is like a wonderful health food plant that you think can solve world hunger. Only the plant is going extinct. There is nothing wrong with the plant. It's the soil that's poison. Similarly, it's not because of the characteristic of the growth mindset itself, but rather it is the egoism that it's planted in. After all, passion and perseverance, first and foremost, require a feeling that there is something worth being passionate about and persevering for. Egoism today is the cause of the malaise, not a place to grow a cure. However, when it is a collective perseverance for a passionate growth together, founded in you and your friends together using your skills or learning for each other and others in general, that eudaimonic happiness, true happiness, is indeed just the soil that a growth mindset needs. So how do we do all this? Let us now then proceed to the details of the approach. Warm-up exercises, physical, stretch, and fun warm mental stretch in a circle. What food am I? How many think the following is true about the teacher? Simple circle connection games. things that wake the individual mind and begin to awaken camaraderie between the students. Workshops are questions that go round robin, but in a unique manner. No one is more important or less important. Everyone is very important. Students don't compete, they add and complete. They do not think ahead to look smart or like great speakers, but honestly say what comes to mind and heart with their turn. While one is speaking, the others try to see themselves within him or her, joining into his or her thoughts and voice. So too, each speaker tries to sense all the others as though all their thoughts were joined in him or her, coming out through the speaker's unique personality and perspective, to blend again with everyone else in the group. The question goes around once or twice or three times till refined into a unified answer representing, as it were, the center of the group. How will the teacher know when it is time to go on? Asking directly may not get honest answers due to shyness or even students not being fully in touch with their own feelings, nor balanced on representing the group as a whole. Look for body language, vaguer than oral, but learnable and touching on a deeper level of psychology, certainly a better look into an individual. However, this does not necessarily reflect the true mood of the group. Deeper still is a je ne sais quoi capability to sense the collective emotional state that is termed emotional aperture. However, an emotional aperture measure, EAM, has been established to assess one's ability in this. In general, this mood is in flux, and the members of the collective subliminally influence each other like waves and reverberations. Stories are something special, one of two parts of true learning. In 1815, the poet Samuel Taylor Coleridge proposed the concept of willing suspension of disbelief. The reader's willing suspension of the reader's agreement to accept the provisional truth of fiction in poetry by granting to shadows of imagination a temporary credulity that willing suspension of disbelief for the moment, which constitutes poetic faith. In 1876, the philosopher Hans Vander proposed the parallel concept for art and literature in general of als ob, German as if. This is the philosophy of as if, an idealistic attitude basic to human motives. For the sake of some desired goal, we accept as if a true proposition that is known to be false. In responding to the arts, readers and viewers accept a fiction as if it were a representation of the real. Regarding the mere amusement value of today's movies, video games, and general audiovisual candy, a thin interpretation of these ideas are merely to chill out and have fun. However, the depth of the matter is to free one from perceptual slavery to the outer peel so as to partake of the inner fruit, receiving the perspective of inner message to the work's creator, the inner message of the work's creator. Experienced educators, who make the best storytellers, know how to use this in the sense of educare to bring the understanding of difficult ideas to individual students so to mold and train them. They have mastered the writing of the Kolb cycle of experiential learning sufficiently to bring it into the virtual experience, even more important in the global era, poignantly so under the shadow of pandemic. Truly excellent educators can actually use stories in the sense of educare to draw up the individual students to the level of application of these ideas and creativity on the basis of them, to the highest peaks reached by climbers of the Bloom taxonomy. Far above these are a new breed of educators who, even during this writing, are striving for the breakthrough of not merely drawing up the individual students in the academic world, but to draw them up out of themselves into a sense, hopefully even a literal, unity with their fellow students. Here it would be not an us versus them unity where there is the horror of an in-group and an out-group, but a universal, all-inclusive, ever-open system. They will sense warmth and security as no students in a classical educational environment could. They will access directly a greater sense of mind and group efforts as a single student with a single heart. Each will experience the eudaimonic satisfaction of his or her special contribution to the collective. Unlike an individual in competition, where only such traits as intelligence, eloquence, coordination, artistry, or athletic ability count, in the group action world, abilities in encouragement, management, leadership, connection, materials organization, general planning, or simple efforts in loyalty, dependability, and willingness to do what needs to be done all count equally to those and are equally appreciated. On one's own, one can spin his or her wheels aimlessly, uselessly. However, every cogwheel, large or small, in a complete mechanism counts equally and is very important. Gamification is the other part of true education. Surely, truly modern education. As a cohesive team, or if necessary for practical or technical reasons, teams in the plural, the students enter the story, bringing it into the greater experiential, since the students don't receive the story, but generate it and live it. Proper manipulation of theme, preferably structured as a hero's journey, and the challenge flow path between the canyon walls of frustratingly difficult and boring ease do not aim at merely duplicating an escape room experience to somewhat tighten up a loosely knit egoistic team. Rather, the goal is to bring the students ever more into a mutually concerned, multidimensional singularity, into something greater, wiser, and more emotionally fulfilling than they have ever experienced in their private lives. Roundtable discussions, free-flowing, will also direct feedback from students concerning their feelings about the process that they're going through. This would also be on occasion to unearth any conflicts and begin to apply role-playing, connection games, and general collective intelligence in their resolution to everyone's satisfaction, not forced and virtually guaranteed unstable compromise, though a compromise may prove a useful starting point. There are some aspects to this approach, and even these still under development in real time with real students. However, the bottom line is that even if nothing completely new and magnificently powerful is accomplished for these precious pioneers, they are still aimed at the cutting edge of a most enjoyable, emotionally satisfying program of academic and social success that will stand by them in their personal lives, later educational endeavors, and as leaders in the workplace and society at large of an ever more integral world. However, for now, they will need a scorecard. Actually, it is our scorecard. At the time of this writing, evaluation methodology is an active area of research and development, and in an even more preliminary state than the approach. Not all that will be discussed here will be implemented, at least at first, and significant changes and additions are likely even in the near future. Experience, not theory, remains the best teacher. However, what follows is the general direction being looked at for initial practice. Before we can have an evaluation methodology, of course, we need to know what it is we wish to measure. As the saying goes, asking the right question is half the solution. Per the earlier discussion, we may identify, at least to start, 4 areas beyond standard individual academics. A, social cohesiveness, B, emotional uniformity, C, trust, and D, academic group performance. Each of these is themselves multifaceted. Social cohesiveness measures emotional satisfaction, self-esteem, in affiliating with the group, attachment to specific individuals in the group, a general sense of group belonging, and identification of self with the group. This measure, as all to follow, has importance in at least verifying that we have been at least as successful in the state of the art and hopefully have gone a little, if not much further. However, its particular importance is in establishing a value to the individual concerning special pleasantness of the learning environment. The present plan for social cohesiveness measures centers on a specific survey technique. It was developed by Lee and Robbins in 1995. Deep credit. Emotional uniformity relates to the concept of emotional aperture, the sense that a group demonstrates an emotional center. It would seem to follow that the more a group unifies, the more thoughts and emotions should center, be this perhaps into a multifaceted superposition state. It would be useful to study how much initial variation occurs in the collective and the nature and rate of its relaxation under different environmental conditions. However, there is preliminary danger of even assuming a relaxation model in group emotion. Freud used such a general model in his psychoanalytic theory for the individual, assuming the human brain to be analogous to a passive resistor-capacitor electric circuit, which later proved to be false, the brain being more accurately modeled as an active transistor electronic circuit. This could always prove to be the case in the external brain of the group network. It is also possible that each type of emotion is different in this respect, as in individuals, each acts as a discrete category as opposed to just a state of a general category. As always, every effort must be made to assure that data is analyzed with an unprejudiced eye. Emotional uniformity would be addressed by using the type of video clips made for emotional aperture measure, or EAM, training. These are clips of different groups of people reacting to various emotional jolts thrown at them, allowing observation of how, in general, waves of feelings tend to travel, rebound, settle, and center amongst the participants. Only here it would be of the particular student group only, and more extensive. Trust looks at the sense of mutual responsibility in the group. How much does each member feel that they can trust each other member? How much they trust the group as a whole? How much does each group member think that he himself or she herself can be trusted by other group members? And how much does each group member feel that he or she can be trusted by the group as a whole? This measure, in a very down-to-earth sense, could be considered the most important measure of all. Trust is mutual responsibility, dependability, guarantee. The glue of relationships of family and friends, work in society, the globe. It is the blood supply of economy and prevents the blood flow of war. It is nothing less than the basic survival and thriving of humanity. Trust would be measured in some combination of survey based on Likert psychometric scales and virtual dramas about the classic game theory scenarios of The Prisoner's Dilemma and The Tragedy of the Commons, trying to invert their standard hopeless results. Academic group performance measures performance of the collective versus its individuals. In regard to trying to tap into evolutionary and breakthrough revolutionary advancement, the prior measures only give us feedback to know if we are properly incubating for such. It is this measure, however, that is what we need to scrutinize to know if we've reached at least state of the art and if we have, in fact, gone far beyond this, and if so, how far. Finally, academic group performance would be looked at through direct problem solving and creativity tests in combination with project-based assessments. There are a number of matrix-based analyses, tensor, Markov chain, fuzzy logic, and neural network, in the literature that have been used successfully for individual and group assessments and in different educational contexts. Some of these might also prove particularly useful here. Summary and conclusion. The greatest practical interdisciplinary concern of modern science, the very survival of humanity into a good future, may be in the long run have been solved through the continuing evolution of the most abstract integral scientific method of reality of all time. Whether we can successfully crack this cosmic egg or not waits to be seen. However, as shown, when such a crucially valuable quest can be pursued at practically no cost, with at worst not collateral damage, but rather only collateral advantage to our students, there is every reason to proceed full speed ahead. We owe it to them and their future to at least try. All the great ideological movements and efforts at supposed world reform have only taken us to the precipice, for they have not addressed the one true corrupter, our own egoism. Even if we cannot of our own reach over the rainbow to establish humanity united above this, then let us at least gain what we can through the attempt. Perhaps high reality will smile upon our hopeful efforts here, and we may find ourselves most pleasantly surprised. Acknowledgements. Integral collaboration can hardly be discussed unless there was some. I thank all those listed in this slide. They do not necessarily agree with my overall approach, much less all the details. Further, they are certainly not responsible for any errors. However, what I've gained from them all, including some valuable feedback and even simple encouragement, did help me a great deal to make this presentation possible.